Okay, so we will see numericals on impact of. Okay, so two small spheres A and B made up of different material move up on frictionless surface as shown in figure. If E coefficient of restitution is 0.8, find the velocities after the impact and energy lost. Okay, these two things are to be found out. So explanatory figure: a surface like this on which two small spheres A and B having 3 kilogram and 1 kilogram weight. This 3 kilogram weight sphere is moving towards right with a speed of 2 meter per second, and this with 3 meter per second towards left. Okay, uh, as per the sign conventions, we assume velocity is acting towards right hand side as positive. Okay, now m1 is 3 kilogram, u1 is 2 meter per second, m2 is 1 kilogram, u2 is minus 3. This is acting towards left, so I have taken it as minus. Okay, next, uh, first conservation of momentum: m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Okay, applying this, what we get is 3v1 plus v2 is equals to 3, the first equation. Okay, now keep it as it is, go for the second. So we have got E is equals to minus into bracket v2 minus v1 upon u2 minus u1. So putting the values, respective values, 0.8 is equals to minus into bracket v2 minus v1, we don't know both, minus 3 minus 2. Simplifying, what we get is v2 minus v1 is equals to 4. Now we have got these two equations within v1 and v2. Now we can solve them and we can find the values of v1 and v2. The values are like this. So v1 is equals to minus 0.25 meter per second and v2 3.75 meter per second, positive value. So this negative value indicates that this is in negative x direction and this is in positive x direction. Okay, so the next question asked was about the energy lost during the impact. So for to find out the energy lost, we can use this formula. Okay, m1 m2 into bracket 1 minus e square into bracket u1 minus u2 bracket square divided by 2 into m1 plus m2. So using this we get 3.375 joules. Okay, this is it. Next question is typical, many times asked such questions. Okay, so a ball is dropped on horizontal floor from a height of 1 meter. Okay, and it rebounds to a height of 0.8 meter again. Find coefficient of restitution. Simple figure: a surface like this or ground, a ball is dropped from 1 meter, it strikes the ground and rebounds again to a height of 0.8 meter. We are asked to find coefficient of restitution. Okay, so we proceed like this. First, applying work energy principle for this motion A to B. Okay, so A to B work energy principle says work done is equals to change in uh, change in energy, kinetic energy. Okay, okay, so mgh, so m mass, g acceleration due to gravity, and h this height 1 meter. Okay, is equals to 1 by 2 m u1 square, half of mv square, kinetic energy. Okay, initial kinetic energy is 0 because it starts from rest here. Okay, so from this we get u as under root 2 gh. Okay, u is the velocity of the ball while coming down. Okay, so it is to 4.429 meter per second in downward direction. Next, after the impact, when the ball bounces again 2.8 meter, so mgh1 is equals to half mv1 square. Now here we can put h1 as 0.8 meter, Okay, so we get v1 as under root 2 gh1, so we get v1 as 3.962. so this is velocity of the ball when it bounces back up to height of 0.8 meter. Okay, so we have what initial velocity of the ball, we have what final velocity of the ball, so we can find out E as minus of v by u, and v by u is, this is 0.894. okay,